let's find the remaining sides and angles if possible. Okay, in this case, looks like I can end up with two triangles because I have two missing angles, okay, which could lead to two different triangles. All right, so let's start off with the first one. Let's acknowledge that this is probably going to be beta 1, gamma 1, and C1. Let's start with beta 1. Okay, so remember beta, we use the law of sines, so sine of beta 1 over b, that's 14, is equal to sine of 30 degrees, which is alpha, over a, which is 7. Multiply both sides by 14. I can actually reduce that a little bit, make my life a little bit easier. 14 over 7 is just 2. And sine of 30 degrees is actually just 1/2, so I can simplify this even further. And 2 times 1/2 is 1. I actually don't really need to do this with my calculator at all. So sine of beta is equal to 1, which means that beta 1 is 90 degrees, right? Because sine equals 1 at 90 degrees. Okay, let's talk about beta 2 for a second. Remember, beta 2 can be found by taking 180 degrees minus beta 1, which comes out to 90 degrees. Ah, look at that. They're the same. So I don't have a separate triangle after all. I get the same triangle again, so I don't have to worry about beta 2. All right, so I'm going to get rid of the 1s altogether. All right, so now let's find gamma. Remember, gamma can be found by subtracting 180 degrees minus 90 degrees minus 30 degrees. That comes out to 60 degrees. So gamma is 60 degrees. Let's say 30, 60, 90 triangle. Okay, so now let's find side C. Side C. Okay, so C over sine of 60 degrees is equal to 7 over sine of 30 degrees. Okay, and now let's go ahead and multiply both sides by sine of 60. And we know that sine of 60 degrees is the square root of 3 over 2. And we know that sine of 30 degrees is 1/2. Okay, well, let's kind of clean this up. Remember, when you divide by a fraction, you're really multiplying by its reciprocal, which is 2 over 1, which of course is just 2. Okay, so what happens here? That will cancel with that. I'm left with 7, the square root of 3. Seven, the square root of 3. Whoops. Okay, now, maybe you recognize the fact that one of those sides was 90 degrees. Okay, if you notice that, then you know the Pythagorean theorem would hold. Okay, you have a squared and b squared, and you need c squared. Right? Well, sort of, actually. Let's be a little careful here. Okay, the reason why I want to be careful is because this is really taking the place of the hypotenuse, right? Because it's across from the 90-degree angle. So this Pythagorean theorem, although it is the same thing, would be something like this one equals this one. A squared plus c squared equals b squared, right? The letters are kind of weird, but remember the hypotenuse, which is usually c squared, is the side across from the 90-degree angle. And since the 90-degree angle is across from what we are now calling side B right in this moment, then b squared will be where c squared used to be. I hope you followed that, right? Okay, so let's try that out. So 14, put this here. So a is 7, c is my unknown, equals b squared, which is 14 squared. So 49 plus c squared is equal to 196. Subtract 49 from both sides, and I get 147. Then the square root of 147. Well, let's break down 147. That's what, 7 times 21. 7's a prime number. 21 is 7 times 3. So 2 7s and a 3. So let's multiply the 7s together. That's going to be the square root of 49 times 3. That breaks up. Square root of 49 times the square root of 3. And the square root of 49 is 7. Okay, so maybe you prefer to do that. I think the law of sines would be easier, but this works as well. All right, so let me just go back to the final answer. Here we go. So alpha 30 degrees, beta 90 degrees, gamma 60 degrees, A 7, B 14, and C 7 the square root of 3.